Hey everyone, let's talk about another way to find volume with rotation except for the disc and washer method we did in 6.2. This is 6.3, it's called the shell method. Let's take a look at a problem like this. I want to do y equals 3x minus x squared. So this little area right here, and I want to rotate it like this. So it makes a shape like this, called a bundt cake in case you're curious. So I'm going around this way. So I have a bottom and a top, which means I need a dy. So if I have dy, I need everything x equals. So let's take this problem and solve for x equals. And I'll wait because you can't do it. This problem cannot be solved for x equals. So we can't do this the way we would normally do it. I need x equals, but I can't get it. Since we can't solve this for x equals, we cannot do our usual top minus bottom routine. It's called the disc or washer method. But what if we cut the cake weirdly? Okay? What if I cut it vertically? So I'm cutting it this way. What am I making now? I'm making a vertical rectangle that rotates all the way around. What shape would that make? Well, it would make something like this, like a hollow cylinder. Those shapes are called shells. So I'm going to do the same thing I normally would do. I'm going to take some sort of integral to add up all of these shells. So let's talk about how to do this. If we could take the volume of an infinite number of shells, we'd have the volume of a solid. The volume of the shells is 2 pi RH. That's the volume of a cylinder. But what's the radius and what's the height? Well, take a look at this. The height of this shell is the function, 3x minus x squared. The radius is x minus whatever axis you're rotating it around. So in this case, it's x minus -1 or x plus 1. If you can remember these two things, all of these problems are easy. So I've got 2 pi RH. I can take the 2 pi out. R is x plus 1. H is x squared, or 3x minus x squared. Sorry, I forgot the dx. What's missing? We don't have any bounds. Since we're doing integration by dx, I need the x bounds, the left side and the right side. And in this case, it's 0 and 3. This is how to set up a volume problem using the shell method. 2 pi, r is x minus axis, h is just the function y. Okay? By the way, you can solve this using a calculator. I'll let you do that on your own time. Let's try one like this. Find the volume generated when this shape is revolved around the y-axis. So another bundt cake type problem. If we wanted to use disc and washer method, we'd have to use dy and solve for x equals. But we can't. 2 x's. Can't solve this for x equals. So we have to use shell method. Shell method says 2 pi RH. Well, r, if I want to go around the axis, I said the y-axis, so just 0, x minus 0. H is just the function. And my bounds are from 2 to 8. So setting up this shell method problem is 2 pi, 2 to 8 are the bounds, x minus the axis, x minus 0 in this case, times the height, which is just the y equals part. Once you have it set up, it's a pretty simple integration problem, especially because I'll let you use a calculator on it. So, plug it into your calculator, second trace 7, you get 160 pi, or about 502.655. Shell method is used to find rotational volume when you can't do top minus bottom because you can't solve for x equals. Okay? If you have any questions, come talk to me. Thanks, guys.